we go through the extending questions 18 to 21. This one's a lot easier than you would think. First of all, notice where these points are. 3 square root of 3, and 3 is in quadrant 1. Minus 4, so that's a negative x, but positive y is in quadrant 2. So if I were to just randomly draw these in a Cartesian graph, and we'll make them both red lines, and we'll just say, okay, well, this one goes to this point, this here, and this one over here goes to this point. Oops, sorry, minus 4, come on, a little bit higher than that, like that. We can easily draw a triangle. Let's focus on the right-hand side triangle first. Just draw a triangle straight down and straight across. And you'll notice that the height of that triangle is the same as the y. And that the length of that triangle is the same as this. And yeah, we could spend time figuring out the length of that ray, but it doesn't really matter because the ray continues on. What they want is they want this angle here. But we can't figure that out without sine cosine law. But we can figure out this angle here and this angle here. Then we can take 180 and subtract that angle and subtract that angle, and we will get this angle. Well, fortunately, this angle here can be determined in radians. Let's say it's in radians, because that angle, the tan of that mysterious angle, it's called angle A, is equal to opposite over adjacent square root 3. Opposite over adjacent. So all I have to do is make sure my calculator is in radians, because they want the answer in radians. I'll find the sine of the angle formed by the two rays that start at the origin. Find the sine of the angle formed by two rays that start at origin. One passes through this point, the other passes through that point. Okay, well, let's focus on the sine then. Let's find this hypotenuse of this one first. The hypotenuse of this one is going to be the square of this number, 9, plus the square of the other number. What's the square of the other one? It's 9 times 3, or 27. 27 plus 9 is 36. And of course, does this 36 have a square root? Of course it does. 6. Let's go and look at this one. What's the height of it is this value here. And the length is this value over here. What's the square of 4? 16. What's the square of 4 times the square root of 3? It's 16 times 3, which is 48. 3, which is 48. And then 48 plus 16, 54, 64. What's the square root of 64? 8. 8. Now, ideally, they want, I believe, to find the sine value of this angle. But let's first find these angles and go back to what I was doing. I can use tan still to find this angle, and tan here to find that angle. So if I do 3 divided by the 3 square root of 3, let's try it just in degrees first. 3 divided by 3 times the square root of 3, both brackets, that's equal to that. And I do the arctan. Let's try that again, because I think I clicked it twice. So it's 3 divided by, open brackets, 3 times 3 square root, close brackets, equals. There we go. And now we've got to do arctan. And we discover that angle is 30 degrees. Let's figure out if that would have worked in the normal way in radians. So 3 divided by 3 times square root of 3. Comes out as that. And that's in radians. And you'd have to do the second arctan. And we discover it's this many radians. Now, if we wanted to figure out how many radians that is in pi, we would divide it by pi, and we get that number. And if you flip that number, you quickly discover that that number is 1/6 pi. So it's the same 30 degrees. So we discover that that's 1/6 pi, which is 30 degrees. What about this one? Well, it's 4 square root of 4 divided by 4. So 4 times the square root of 4, which is 2, which is 8. Oh, it's fair. 4 square root of 3, sorry. So we do square root of 3 times 4. Equal that. Divide by 4. And in radians, we discover it's this. If we divide it by pi, we discover this number. Now, this number is hard to figure out. Let's try it in degrees. Oh, I forgot arctan. Stupid me. So we'll try that all over again. Square root of 3 times 4. All divided by 4. Is that? Let's take it in degrees. We're going to do arctan. And we discover 60 degrees. Now let's try it in radians. We got 3 square root times 4 divided by 4. Arctan. And we get that divided by pi. And you get this number. You divide that. If you flip that number, you quickly divide it. See, it's 1/3. So you discover that this is pi over 3. So this one's 30 degrees, and this one's 60 degrees, which means this remaining thing is 90 degrees. 90 degrees, which means it's forming a 90-degree triangle. That's the A, that's the B. And if you square root that one, 64 plus 36, you discover this other one is 10. Since we're talking about 90 degrees and they want to know the sine of that, the opposite of the 90 degrees is hypotenuse, so you can't really do that, which is why. But we can figure out what the sine of 90 degrees is. The sine of 90 degrees up here is 1. So the answer would be 1. What is the sine of this angle? It's 1. So you have to figure out these two to figure that out, to figure out that's 90 degrees. Assuming they want the sine of this angle, well, we could have also done the sine of these once we figured out these. So it's 3 over 6, which is a half, and the half will give you 30 degrees, or 4/3 over 8, which I don't know how that comes to, but that will give you the 60 degrees, which will tell you that this is pi over 2, or 90 degrees. The sine of pi over 2 is 1. Next one. Same kind of question, ray that starts at origin, passes through one point, passes through the other point. They want to know the cosine of the angle formed by the two rays. All right, well, let's pretend we got a Cartesian graph here. Notice that the first ray goes in quadrant 1 and the second ray goes in quadrant 2 again. So again, we're talking something like this. By the way, this is going to form 45 degrees angle, that first one. Tell me how I know that. This one goes a bit longer than wider. How do I know that this one here forms 45 degrees? Because if I draw a triangle straight down, the height is going to be the y. The length is going to be the x. Since both of these have the same value, the only possible angle that can exist in both corners is pi over 4, or 45 degrees. That's true for any triangle that's a right angle triangle that has the sides that are the same. That's how we came up with our special triangle for 45 degrees. This other one's a little trickier. This other one goes through this point, which means the length on the x value is this, and the height is this. If we wanted to find the hypotenuse, let's find the hypotenuse over here too. 6 times 6 is 36. Square root of 2 times square root of 2 is 2. 36 times 2 is 72. This one's 72. which means when we add it together, we would get 144, and the square root of 144 is 12. This over here, that's 49 squared. That's 49 times 3, which is 147. 147 plus 49 gives me 196, which I think is 14. 196. Yeah, 14. Which means this one is 14. Which means the cosine of this angle is the adjacent over that. We don't need to do this one, but the cosine of this one is that over that. And it's going to give you that. But let's figure out this one first. Let's use the tangent. Or let's use the cosine. What's this divided by that? We're going to make this positive just to find the acute angle, though. So what is, we'll do it in degrees first. What's 7, or the square root of 3 times 7 divided by 14? And that will be the arc cosine. It's 30 degrees. Let's do it in radians. What's 3 times, 3 square root times, let's try that again. 3 square root times 7. Turn it into radians, and we'll divide it by 14. And we'll do the arc cosine. We're going to divide that by pi. And we discover 0.11166 again, and when we flip that upside down, that's 1/6. So it's definitely 30 degrees. So we're talking about 40 degrees. Pi over 4 plus pi over 3, what is that? It's 3 pi plus 4 pi over 12. It's 7 pi over 12. If I take this whole thing here, which is 180, which is pi, and subtract 7 over 12, pi is the same as 12 over 12 pi, minus 7 over 12. That gives me 5 over 12 pi. For that angle here. What's the cosine of 5 over 12 pi? That's the angle. So we just take the cosine of it. And we don't get what we want. So let's try to do it with degrees. What's 30 degrees? 45, that's 75. What's 180 minus 75? It's that. What's the cosine of that? Minus 0.2588, because it's over 90 degrees. Let's find it for the way I was doing it. And we're going to do the cosine of it. There we go. We get the same. Oh, this one's positive, though. Weird. 3 and 4, 7 over 12. That leaves 5 over 12. 5 divided by 12 times pi. 12. And we'll take the cosine of it. Yeah, for some reason that's coming out as positive. Doesn't matter. So that means that angle there is 5 over 12 pi, or 105 degrees. And then you take the cosine of it to get to the nearest hundredth. All right. At least I think that's what they're going for. Okay, 20 is straightforward. It helps for number 20 if you know what the cosine curve looks like. So she says, Julie notices that the range of sine functions go from -1 to 1. She then begins to wonder what the reciprocals of these functions are. Okay, so here's a sine curve. It starts at 0, 0. At 90 degrees, it goes up to 1. At 180 degrees, it goes to 0. At 270, it goes to -1. And at 380, it goes to 0 again. So we're going to 0, 0. And let's do all these spots over here. 1 pi 0. And 2 pi, 0. The peak here is 90 degrees, which is pi over 2, 1. The peak here is 3 pi over 2 at -1, like that. If you were to take the reciprocal of 1, and all the degrees are the same, the reciprocal of 1 is 1. But notice that any number on the y-axis here is below 1 all the way down to 0. If, let's say at 0.5, you're to take the reciprocal of 0.5, you get the answer 2, which means any reciprocal of a number below 1 to all the way to 0 is going to go higher than 1. So it's going to look like this. So what's the reciprocal of sine? Cosecant. Now what's interesting is when we hit 0, you can't take the reciprocal of 0. It creates an asymptote. It also creates an asymptote over here when it hits 0 again. At pi, I haven't quite drawn the graph correct, but right there. What happens at the bottom here? It's the same thing, except that it's going to go here, and the part they're going to have in common is at -1 and 1. So they're both going to share this 1 right there, because the reciprocal of 1 is 1. They're both going to share this -1 right here, because the reciprocal of -1 is -1. And you can prove this by pulling up, you can either pull up the sine curve on a Desmos. As soon as my graph starts going here. There we go. And you can either do it this way. You can do 1 is equal to sine x. And you can do 1 is equal to cosecant x. And you'll see it touches at all the ones. And notice that the asymptotes are x is equal to 0. X is equal to pi over 2. Actually, x is equal to pi. Yeah, it's pi. And x is equal to 2 pi. And that's where your asymptotes will be. You can also, instead of do cosecant x, you can do 1 over sine x. Same thing as cosecant x. And you can see why the reciprocals go up, and that actually for cosecant, it never goes between 1 and -1. It touches 1 and -1, but it never goes in between 1 and -1. Same thing for cos x. I won't bother you because cos x is simply an out of phase sine x. And it's going to have the same rules. It's going to touch the 1. This time the asymptotes will be at x is equal to pi over 2. And x is equal to 3 pi over 2. And repeats every pi. So there you go. You can also call this secant x. There you go. Like that. And as you can guess, the tangent's the only one that won't quite follow that rule, because tangent doesn't have a restriction between 1 and -1. Instead, cotangent and tangent are going to look very similar. And there we go. Now, what's the last question? The last question is, the terminal arm of pi is in the fourth quadrant. If cot pi is equal to -3, you can calculate sine times cot minus cos squared. All right, let's try this one. Terminal arm is in the fourth quadrant. In the fourth quadrant over here, only cosine is positive. So we just know the terminal arm's like that. But we do know the cotangent is minus square root 3 over 1, which means the tangent is 1 over square root of 3. But let's just stick with the cotangent. Since cotangent is going to be the opposite, it's going to be x cosine over y sine, we know that the x must be square root of 3, and the y must be -1. So we're in quadrant 4. Now that we have that, we can take the square of that, which is 3, the square of that, which is 1, add them, we get 4, and square root of this, which is that. Right away, this looks very similar to our 60-degree triangle, where this is 30 degrees and that is 60. But we now have sine of the angle. Keep in mind the angle is right down here. The sine of this angle is -1 over 2. The cosine is square root 3 over 2. And the tan, we already have it, but we don't need it. We just need the cotangent. Cotangent is negative square root 3 over 1. So if we put that over here in this formula, we can just skip this part of the graph now. And we just say, okay, let's reproduce everything. Well, I know sine is this, -1 over 2. Cotangent is this, minus this squared, square root of 3 over 2 squared. What is that squared? We get 3 over 4. So -3 over 4. Keep in mind this minus here is separate from the square. So -3 over 4. What's happening here? Let's put the 2 down here. -1 times -3, or square root of 3 is, times negative square root of 3 is just square root of 3. And 2 times 1 is this. So we get square root of 3 over 2 minus 3 over 4. We have to put this over 4, so we multiply top and bottom by 2. We get 2 square root of 3 minus 3 over 4. And we cannot really make that any simpler. We can do this over that if you wanted to, but it's the same thing as going back to this. And you could calculate it if you want. But this is the non-adjusted exact value. Assuming I got all my math right, you'd have to go back and make sure sine times the cot will be positive square root 3 over 2. Yeah, cot squared is definitely 3 over, cos squared, yeah. Square root of 3 becomes 3, and this becomes 4, so it definitely becomes -3 over 4. So that should be the answer.